The next one is Schrodinger's wave equation. Before I give you the mathematical expression for this Schrodinger's wave equation, let us learn how this Schrodinger's wave equation was introduced. Okay, now from the previous topic, that is uncertainty principle, we have learned that both the position as well as the momentum or velocity we cannot precisely determine. Okay, that is, or simultaneously we cannot determine both the position as well as the momentum or velocity for any small moving particle. Now therefore it is not right, or it is not appropriate in saying that the electrons move with a fixed velocity, okay, around the nucleus in a fixed orbit with definite radius. Okay, therefore it is best, okay, to speak in terms of the probability of finding the electrons in the space around the nucleus. Now because of this uncertainty principle, the idea of the Bohr's definite orbits, okay, does not appear to hold good. However, the Bohr's concept about the fixed energy levels in an atom has found to be helpful to describe the atomic spectra. Okay, so with this view, okay, a new atomic model have been introduced by following some of the aspects. So those aspects are: the first one is the wave nature of the electron. The second one is the idea of uncertainty in the position of electrons in the atom. And the third one is the concept of fixed energy states. Okay, so the atomic model which takes into account all these three aspects is commonly referred to as the wave mechanical model of atom or quantum mechanical model of atom. Now in this model, okay, the behavior of an electron in any atom is described by the equation known as the Schrodinger's wave equation. So mathematically the Schrodinger's wave equation is delta square psi by dx square plus delta square psi by dy square plus delta square psi by dz square plus 8 pi square m by h square p minus v psi equals to 0. Okay, here the psi is a function, okay, of space coordinates, that is x, y and z axis respectively. It represents the amplitude of the electron and it is called the wave function. Okay, that is psi is called the wave function. Then m is the mass of an electron, capital E is the energy, okay, the total energy of an electron. Then V is the potential energy of the electron, that is given by E z square by r. Okay, then h is Planck's constant and delta is for infinitesimal change. Okay, now from this particular equation, okay, from this particular equation that is known as Schrodinger's wave equation, we can solve for psi. Okay, and since a large number of solutions can be possible, that's why in order to obtain a meaningful solution, three integers, that is n, l and m, okay, were introduced, and these three integers are called the quantum numbers. Okay, there is another quantum number, that is s. Okay, so this spin quantum number is based on another concept, okay, that was included in quantum numbers. Now I want you to go through the important features of the quantum mechanical model of atom. Okay, then the next one is the physical significance of psi and psi square. Okay, psi and psi square. Okay, psi is a wave function which will give you the overall property of an electron. Okay, and psi square is the probability of finding an electron at a point, okay, within an atom.